All right, welcome to chemistry lesson 6.02, the first of two videos on drawing Lewis structures. So we're going to go through four examples of Lewis structures, and we're going to go through the rules that you have to apply. And the definition of a Lewis structure is a diagram that shows covalent bonding in the simplest form. It's a diagram that shows covalent bonding. And if we're going to be more specific, we could say covalent bonding in the valence electrons, because it's always the valence electrons that do the bonding. And so for example one, let's put example one down here. Let's do a fluorine and a fluorine. Remember back at the beginning of the year, you had to memorize the diatomics, and you memorized that hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are diatomic. Well, today we're going to see why. So if I take the Lewis or electron dot notation for fluorine, which we're not going to do this for all of them, I just want to do it for fluorine. We have 7 valence electrons. Remember, we get those valence electrons by the column that it's in. Basically, what we see is going to happen, and on this one, I'm going to actually do the diagram first, and then we'll show you, you know what, let me do, shoot, I'm going to kind of overtop these in blue. So if these two come together, right now this has 7 valence electrons and this has 7 valence electrons. So if these two come together, the left fluorine has its electrons in red, and the right I'm going to do in blue. If I count the electrons around each of these fluorine, and these represent the nuclei, so this represents the nucleus of the atom. So over here I had 7 and over here I had 7, but look what happened now. I've got 1, 2, 3, 4, 5, 6, 7, 8. And over here I have 1, 2, 3, 4, 5, 6, 7, 8. By sharing this single electron that they have, they now have created a molecule, and this is in fact a molecule of diatomic fluorine that has each atom has a valence. It has 8. So as we do these, the first rule is that at the end, the final structure every atom must have an octet, except, whoops, oh, I need my whiteout. Must have 8 valence electrons, except there are 2 exceptions. Hydrogen only has a 1s orbital. So if hydrogen has 2, that's a full valence for hydrogen. That's the most hydrogen can have. And boron is a metalloid. Boron does weird stuff. We're not going to see too much of boron, but boron can only have 6. So if you have a structure that has boron, when you're done counting it, you want to count 6. That's full for boron, and for hydrogen, you're going to have 2. The next rule is we are going to replace, so let me label some things here. These 2 electrons that are between the fluorine atoms are called bonding electrons. Bonding electrons. These here and here are non-bonding electrons. So all the others here, here, these are non-bonding electrons. These are the electrons that are responsible for keeping this molecule together. So these are my bonding electrons. Rule number 2 is we represent the bonding electrons with a dash. We represent the bonding electrons with a dash. So the final Lewis structure for this would look like this. I replace those bonding electrons with a dash, and I put my pairs then around the outside. And this is the final Lewis structure for 2-fluorine. So that's my final right there. All right, let's start with a second example. Let's go with example 2. What if I'm going to bond together 3 fluorine and 1 nitrogen? So I'm going to bond 3 fluorine and 1 nitrogen. How do I even know where to begin? Rule number 3 is that the, let me go to orange. So we have to kind of put together a skeleton. So when we assemble our skeleton structure, the least electronegative element is central. The least electronegative element is central. So that's kind of the rule of thumb. So in this case, if I have 3 fluorine and I have 1 nitrogen, fluorine has the highest electronegativity on the periodic table. So we're going to be looking at putting nitrogen in the center. So I'm going to put nitrogen here, and I'm going to surround it by my fluorine, like this. But I don't, at the end, I don't know exactly where to start with this. Well, it turns out that you have to get a total of the valence electrons here and the valence electrons here. Your final structure can't have more valence electrons than we have with 1 nitrogen and 3 fluorine. So what I have to do here is I have to make a little table and calculate my allowable valence electrons. I have fluorine and I have nitrogen. I have 3 of these fluorine and I have 1 of these nitrogen. Each fluorine comes in with 7 valence electrons, and nitrogen has 5 valence electrons. So when I calculate this, I'm going to have to kind of come down here. I don't want to get into the next column. 7 times 3 is going to have 21. So I'm going to have 21 valence electrons from fluorine. My nitrogen is going to contribute 5. So I can't have more than 26 valence electrons here. So rule number 4 is that the final structure, the electrons in your structure, cannot exceed your max allowed, the maximum allowed, which is your total for all your elements. And I just realized we're going to need a number 5. So hopefully you didn't, I don't know if you have room to squeeze that in or not, or we can write it over here. I'm going to leave room there for a number 5. All right, so when I begin to assign electrons onto these guys, I'm going to start around the outside. I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So what you're going to have to do is you're going to have to do checks for this at the end when you want to check your structure, and you have to do a check for this. So I know I have 26 electrons, 2, 4, 6, 8. 10, 12, 14, 16, 18, 20, 22, 24, 26. But does every atom have an octet? So if I go to fluorine, I've got 2, 4, 6, 8. Fluorine's good, it has an octet. When I go to this one, does this have an octet? Yep, 2, 4, 6, 8. How about this one? 2, 4, 6, 8. Yep. And this guy's got 2, 4, 6, 8. So this meets all the rules for Lewis structures. Everybody has an octet. So now I need to redraw it so that I have a dash. So I'm going to have my final structure is going to be nitrogen, fluorine, fluorine, fluorine. And I've got this pair here. This guy has a special name. So when we have an atom that has a pair like this, we call this a lone pair. This guy's got, you know, all these pairs, but this is, we're going to use the term lone pair, and that's a pair of electrons on an atom hanging out by themselves. So as we go into part 2, we're going to see that rule number 5, and I'm going to write that down now so that you've got cut space. And let me grab another color. Let's do dark blue. Carbon, nitrogen, and oxygen can form multiple bonds. Can form multiple bonds. So that makes things a little more complicated. This is a single bond. A single bond, which means a multiple bond means they can share 2 pairs of electrons, or 3 pair. So here we're sharing, this represents a single shared electron, but we're going to find out in the next video how carbon, nitrogen, and oxygen can actually do multiple. All right, on to part 2.